Hello, good morning, good afternoon, good day to all of you, my FB friends. So this morning, I will discuss to you the topic on. We have quarter 3, module 2, lesson 2, week 2, then you have D5. This is all about distinguishable permutations. So again, distinguishable permutations. And at the end of this video, you can find the distinguishable permutations of an object. You can find the distinguishable permutations of an object. So, what do you mean by distinguishable permutation? Distinguishable permutation means permutations with repetition. Permutations with repetition. And we have permutations of n things not all different. Permutations of n things not all different. The number of permutations of an object of which P is alike, Q is alike, R is alike, and so on is, we have permutation of n objects taken R at a time is equal to n factorial all over P factorial Q factorial times R factorial. Example, how many different ways can the letters statistics be arranged? How many different ways can the letters statistics be arranged? So we have, there are 10 letters of the word statistics, assuming that the letters are distinct. So we have permutation of 10 letters of the word statistics taken 10 at a time is equal to 10 factorial, or we have 10 factorial permutations. However, we have to take into considerations that the 3 S's are alike, the 3 T's are alike, and the 2 I's are alike from the word statistics. So, from the word statistics, we have how many letters? 10 letters from the word statistics, and that will be our N. So we have permutation of 10 letters from the word statistics taken 10 at a time is equal to 10 factorial. So from the word statistics, how many S? And that will be our letter P. So we have 1, 2, 3 S's. And that would be permutation of 3 S's taken 3 at a time is equal to 3 factorial. So how many T's? There are 1, 2, 3 T's. And that would be our Q. And that would be permutation of 3 T's from the word statistics taken 3 at a time is equal to 3 factorial. And from the word statistics, how many I's? So we have 1, 2. So we have 2 I's, and that would be our R, which is permutation of 2 I's from the word statistics taken 2 at a time is equal to 2 factorial. Or the permutations of the 3 S's is we have permutation of 3 S's from the word statistics taken 3 at a time is equal to 3 factorial. The permutations of the 3 T's from the word statistics is, we have permutation of 3 T's from the word statistics taken 3 at a time is equal to 3 factorial. And we have the permutations of the 2 I's is, we have permutation of 2 I's from the word statistics taken 2 at a time is equal to 2 factorial. So, we are going to divide 10 factorial by 3 factorial times 3 factorial times 2 factorial in order to eliminate the duplicates. Again, we must divide 10 factorial by 3 factorial times 3 factorial times 2 factorial in order to eliminate the duplicates. Thus, we are going to use again the formula. We have permutation of objects is equal to n factorial over p factorial times q factorial times r factorial. In our problem, it's all about the word statistics. So we have permutation of the word statistics is equal to our n or number of letters. We have 10 factorial all over. We have our p is equal to 3 factorial. That would be our letter S. Our q factorial is our letter T. That would be 3 factorial times our R, which is the I, equal to 2 factorial. So we are going to process. This will be permutation of the word statistics is equal to 10 factorial all over 3 factorial times 3 factorial times 2 factorial. But what is 10 factorial? 10 factorial is equal to 3,628,800. And 3 factorial is 6. Another 3 factorial is 6. And 2 factorial is equal to 2. So we have now 3,628,800 divided by 6 times 6 is equal to 36 times 2 is equal to 72. So we have 3,620,800 over 72 is equal to 50,400 ways or distinguishable permutation. So the word statistics can be arranged 50,400 ways distinguishable permutation. So let's go to what's more or evaluation. So we have number 1, how many different ways can the letters of the word Tagaytay be arranged? How many different ways can the letters of the word Tagaytay can be arranged? We have from the word Tagaytay, so how many letters has Tagaytay? There are 8 letters and that would be our N. And that would be written as permutation of 8 letters from the word Tagaytay taken 8 at a time is equal to, what will be our P? Our P would be letter T. So how many letter T's? There are 1, 2. 2 letter T's. And that would be permutation of 2 letter T's from the word Tagaytay taken 2 at a time is equal to 2 factorial. So what will be the next letter that is alike? So we have letter A, and that would be our Q. So how many letter A's? We have 1, 2, 3. So there are 3 A's which is permutation of 3 A's from the word Tagaytay taken 3 at a time is equal to 3 factorial. And next, a like letter, so we have Y. That would be our R. How many Y's? There are 1, 2 Y's, so we have 2 Y's, and that would be permutation of 2 Y letters from the word Tagaytay taken 2 at a time is equal to 2 factorial. And using the formula of the permutation of objects from distinguishable permutation, we have n factorial over p factorial times q factorial times 3 factorial. So that would be 8 factorial over what is p? We have 2 factorial, q is 3 factorial, and r is 2 factorial. So you're going to multiply 2 factorial times 3 factorial times 2 factorial. That would be, we have 40,320 divided by 2 times 6 times 2. That will be equal to 40,320 divided by 2 times 6 times 2 is equal to 24. And we have 40,320 divided by 24 is equal to 1,680 ways, or we have distinguishable permutation. Therefore, the word Tagaytay has 1,680 ways or distinguishable permutation. Number 2, in how many ways can 10 books, 2 of which are mathematics 10, 5 science 10, 2 Filipino 10, and 3 English 10, be arranged in a shelf if there are to occupy just one row? Again, in how many ways can 10 books, 2 of which are 10 mathematics 10, 5 science 10, 2 Filipino 10, and 3 English 10 be arranged in a shelf if they are to occupy just one row? So we have from the given number of books, we have 12 books, and that would be our n. So that would be permutation of 12 books taken 12 at a time is equal to 12 factorial. So from the 12 books, there are 2 mathematics books, and that would be our P. And that will be permutation of 2 mathematics books taken 2 at a time is equal to 2 factorial. And we have 5 science books, and that would be our Q. And that will be permutation of 5 science books taken 5 at a time is equal to 5 factorial. And we have 2 Filipino books, and that will be our R. So permutation of 2 Filipino books taken 2 at a time is equal to 2 factorial. And we have 3 English books, and that would be our S. And that will be permutation of 3 English books taken 3 at a time is equal to 3 factorial. So using now our distinguishable permutations formula, we have n factorial is equal to p factorial times q factorial times r factorial times s factorial. So what is n? Our n is 12 factorial because there are 12 books. So we have 2 mathematics book, that would be 2 factorial, 5 science books, and that would be 5 factorial, times 2 Filipino books, that would be 2 factorial, and we have 3 English books, That would be 3 factorial. So you're going to multiply 2 factorial times 5 factorial times 2 factorial times 3 factorial. We have 12 factorial is equal to 479,001,600 divided by what is 2 factorial is 2. 5 factorial is 120. 2 factorial is 2. And 3 factorial is 6. We have now 479,001,600 divided by 2 times 120 times 2 times 6. So we have 479,001,600 divided by 2 times 120 times 2 times 6. We have 479,001,600 divided by 2,880 is equal to 166,320 ways or distinguishable permutation or order of arrangement. So again, we have 479,001,600 divided by 2 times 120 times 2 times 6 is equal to 2,880, and that would be 166,320 ways or distinguishable permutation or order of arrangement. Let's go to number 3. Find the distinguishable permutations of the digits of the numbers 3, 4, 8, 8, 3, 8. Again, find the distinguishable permutations of the digits of the numbers 3, 4, 8, 8, 3, 8. So we have given numbers 3, 4, 8, 8, 3, 8. So there are 6 numbers or digits, and that would be our n. And that will be equal to permutation of 6 digits taken 6 at a time is equal to 6 factorial. And how many threes? So there are 1, 2, 2 threes, and that would be our p. And that will be equal to permutation of 2 threes taken 2 at a time is equal to 2 factorial. How many eights? So there are 3 eights from the given number. So that will be our q. So that will be equal to permutation of 3 eights taken 3 at a time is equal to 3 factorial. So using now the formula of permutation of distinguishable permutation, we have n factorial divided by p factorial times q factorial. So this time there are only 2 digits which are alike. We have now n is equal to 6 factorial over p factorial is 2 factorial and q factorial is 3 factorial. So we are going to process 6 factorial is equal to 720. And the 2 factorial times 3 factorial is just 2 times 6. And so we have 720 divided by 12. The number of distinguishable permutation or ways is equal to 60. And that would be the permutation of the 6 digits is equal to 60 ways or distinguishable permutation. So, you're going to try this. Find the distinguishable permutations of the following. We have number 1, Philippines. Number 2, the word Estela. Number 3, Mississippi. And number 4, your full name. So what will be your full name? You are going to get the distinguishable permutation, or number of ways of order of arrangement. So it's the end of our topic. So next topic will be quarter 3, module 2, lesson 3, week 2. We have day 6. And we have lesson 3 is all about circular permutation. Thank you for watching. Bye. Katong wa pa maka-subscribe, please subscribe. And please do not forget to hit the notification bell for some updates of my videos. For videos, please click here and subscribe my YouTube channel. Thanks for watching.